All right, guys, this is one of your examples for Charles' law. So again, this is one of the problems that was on your PowerPoint already. I'm just going to go through it with you. So in a container, the temperature is measured at 345 Kelvin and a volume of 4.54 liters. If the temperature is increased to 549 Kelvin, what would be the new volume? So again, Charles' law, that is the relationship between temperature and volume. So our formula for this is going to be the volume of the first container times the temperature of the second container is going to equal the volume of the second container times the temperature of the first one. Okay, so V1 T2 equals V2 T1. All right, so from the problem, again, always going to write down first what we are given. So the first volume is we're going to is 4.54 liters. The first temperature that we're given is 345 Kelvin. So remember, we're not just writing, we're just writing out whatever we are given in the problem. It's not always going to be in order like it was with the Boyle's law problems, okay? So the volume of the second container, that is what we are solving for, because we know that because that's the only factor that we're not given in the problem, and the problem itself asks what would be the new volume, okay? So that is our unknown. And something else that we're given in the problem is the second temperature. So that was 549 Kelvin, okay? So now if we're setting this up, all we're doing is plugging in these to this original equation, okay? So this would be 4.54 liters times 549 Kelvin is equal to, again, the second volume, that is what we're solving for, times 345 Kelvin. That is the temperature of the first container, okay? So if we multiplied this out, this would be 2,492.46 equals the second volume times 345 Kelvin, okay? So now to solve this, just like we did with the Boyle's law, we have to divide both sides by 345 Kelvin to get the second volume by itself. Okay, so if you solve this out, V2 would equal 7.22452. If we are rounding that down to the correct amount of sig figs, we need 3 sig figs in our final answer, because in the original problem, this number has 3 sig figs, this number has 3 sig figs, and this number has 3 sig figs, okay? So 7.22452 down to 3 sig figs. Our final answer would be 7.22 liters. Okay?